So what I'll do is I will briefly bring us back to kind of the overall system architecture, just to kind of pinpoint where we are on the map and how we look at it. So fundamentally, when we talk about our EDI engine, which is really kind of the topic of today's discussion, you will notice that we place it in our front tier. Like it's considered to be a client application that interacts with the business server, just like, you know, a web application would, or just like our main operational, you know, client workstation does. So it's basically an engine whose responsibility is to shield the business server, allow the business server to continue processing transactions at, you know, peak volume in a consistent way, validating all the business rules that the organization has, validating all the transitions, and making sure that, you know, the business server is shielded from the variety of events that take place outside. So basically, that's kind of the super high level philosophy of where you know, EDI engine lives and how we think about it. So there are multiple, we like to think of them as like layers of the defense in this communication. So first and foremost, we have our first layer of defense is Mirth Connect, right? So Mirth Connect is basically the engine that we're using to define the transformation channels as they communicate with the outside world. So variety of connectors that Mirth offers for synchronous communication has, you know, worked very well for us. So think of this as your, you know, MLLP plugins and, you know, SFTP plugins, you know, web calls, what have you. So the only thing we were not happy with as far as Mirth is concerned is their ability to do synchronous communication, because we're using this engine for everything, for synchronous, for asynchronous, for communicating with external EMRs, for communicating with instruments, for communicating with, you know, send out laboratories. So everything that our business server at the end of the day will be processing will usually come through Mirth Connect. So what we've done, we've developed our own proprietary plugins for Mirth to facilitate synchronous communication. So there's like Ligo, Ligo plugins. And these are usually geared towards very specific types of instrumentation, or otherwise like customizable ASTM style communications with specific instruments. Like I think we've done a much better job than Mirth on these. So we license their plugins. We have our own. So that's kind of like another layer inside Mirth Connect. So that's transport, right? So if we're thinking about transport, this is where this lives. This is how this works. So then we have kind of like the language layer. So here again, we have a layer called LigoLab XML. So we wanted a language that could represent everything that you find inside our system, inside screens, inside user interface. Like last time, if you remember, we talked about how our system is extendable. Like you can add attributes, right? You can extend any entity. So one of the biggest issues that people have with, you know, getting data in and out is like, how do you describe it, right? Like sometimes, oh, I can run query against databases, or I can, you know, every time I need something, I need to ask for an endpoint, and somebody needs to describe that, you know, JSON for me, or somebody needs to describe this or that so I can, you know, put some data in and or get some data out. So we wanted to separate some very clear scenarios that are basically operationally sound. They're repeatable. We're doing it in them in millions, right? These are the number of transactions. And we wanted to separate like ad hoc things like, oh, management wants a dashboard and they want to, look at something, or they want to extract some data that might be like a multi-year data extraction, stuff like that. So let's treat them separately. What I'm going to be discussing first, and what I want to, specifically talk about LigoLab XML, it's those repeatable transactions, of which, there aren't really that many. Laboratories are extremely kind of varied in terms of what they do, but fundamentally, there are like electronic orders in and electronic reports out. That's as far as communicating with hospitals, right? Like we have some, specific things, like some hospitals might want to send you like electronic ADT messages to get you some patient data and billing. So we definitely recognize that. And we have a little, secret that every laboratory does that, we don't tell our clients, that some of the reports are done somewhere else. So it would be electronic orders to send out, like electronic reports / results from send out, right? So I would say 99.9% of all electronic communication that a laboratory does on a day-to-day basis that needs to be done in like hundreds of thousands, millions of transactions, they fall into, these 5 categories. So what we've done here is we describe these communications using a language we call LigoLab XML. What that language allows you to do is to get as detailed as you want on any one of these transactions. So let me give you some examples. If you have a hospital who is super advanced and they're basically are sending you very detailed specimen information for your, NGYN cytology testing, where they're describing passes that they take, they're describing, all the specimens, all the sites, operations that they perform. For regular HL7, they get very creative for the regular HL7. They stick it in various nodes and they invent their own segments, right? So our system doesn't care about any of that. Like we know, because our system has the same type of rigor in terms of how we represent the specimen hierarchy, how we accept it. LigoLab XML is naturally capable of formulating an electronic order that can receive this detailed information. So all we need is we need a converter inside Mirth Connect. Like this is kind of all out of EDI engine. Let me put it like this, a little umbrella. Like, so all we would need is we would need a conversion from that, homegrown, some, very creative interface engineer at a, banner hospital somewhere. He came up with this HL7 standard. So all we need is to contain that entropy, to contain that mass in a little Mirth channel, right? So this is where we do, and why can't I type HL7 to LigoLab XML conversion. And likewise, when we're sending a report back to this hospital, we have LigoLab XML to HL7 conversion. So that way, our business server works in a consistent manner. It just works with LigoLab XML. Right? Like, let's say you have a guy or a team of people who are really good at establishing simple HL7 interfaces with a bunch of clinics, right? Like, it's a standardized, all you need to do is we need to teach these guys how to do like a sample transformation to our XML. We need to give them plenty of templates, plenty of examples, and let them loose, right? Like, there's like one channel here that's ready to accept electronic orders, and you have your return on investment, right? Like, you're building these interfaces, you're not being charged per interface, like you're doing this. All of a sudden, there is a really complicated interface. Like I gave you an example. Somebody wants to do kind of in-depth pathology interface, or an advanced molecular type of data that's packed differently, or a file format is unknown. It's not like HL7. They want to send you something else with 3 different PDFs attached that need some very specific, like they need to be merged in one PDF so you can, present it on your report. Great. It's a separate channel. You can outsource it to us. It will be our job to convert some whatever XYZ format to LigoLab XML. We'll do it. And the business server doesn't care. It doesn't know. It just receives the same LigoLab XML document. So that's one kind of layer that I wanted to clearly separate, like why answer the question why LigoLab XML. It basically kind of isolates the mess. It always works in a consistent manner. Likewise, if you want some data export that contains some very specific or very detailed information, you can always request that from the system in the LigoLab XML format. Again, you want to do some post-processing. You want to run your own data warehouse, maybe like your own data lake, and you want us to dump like the data in a consistent way. That's another great way to build an interface so you don't have to query, you don't have to ship logs, you don't have to do anything kind of esoteric. You have like a very, very clean data exchange standard. Right? So you have all the variety of integrations with instruments. This is your, order to instrument. Result from instrument. So the only thing that violates this cleanliness is request reply query analyzers who are working off of, what do I do? I have this specimen, you just scan this barcode. Hey, Elias, help me out here. Tell me what to do. So that's why we have these synchronous LigoLab plugins that basically answer queries. Answer query from instrument. Right, so that's all. We have a little bit of synchronicity into the system that, a request comes in, the instrument actually waits for us to reply. Everything else that I've described up to this point was fully asynchronous. So it can be highly paralleled, multi-server, so it's very scalable. This is, unfortunately old remnants of the old lab technology, but it's still widely used. I'm sure you have some analyzers that work this way. So this is synchronous. See, they really have figured out how to do this part really well. Like they offer this incredible flexibility. So we wanted to kind of use that. We wanted all this entropy to go against this shield, and we just focus on what we do well, and like we understand the transactions well. We know how the lab runs. So we let them, we'll let them do it. Policy. Let's say you have multiple sites and you have certain policy or certain rules configured on or certain setting, like how a system should behave. So this screen, for instance, allows you to investigate an effective setting once you've taken into consideration, the global setting for the entire organization. We have multiple applications working, under the umbrella of this system. And then you have different facilities, like every facility can impose its own specificity. And then you have like, but pathologists want something specific, or, this specific user when he's working on this specific workstation. So it can get pretty crazy. If you wanted the flexibility in terms of like how to, and it extends kind of in all directions. It could be as simple as like, oh, which printer we should be printing these cassettes at, to as complicated as, what is the aliquoting policy, depending on, who the client is, what methodology they prefer, how to print labels at what stage. So you could have like a South Carolina office that has like a population of physicians that prefer, this particular methodology, and the system will take it into consideration. If accessioning is happening in your South Carolina office, it would apply the right aliquoting policy. It will generate the right labels and print it, with accessioning. So it can go like from very simple to very complicated. And you will find similar tracks. Like I wanted, some example where, you could come to a test setup and say, well, I would like, by default, this is what my test does, right? I have, a simple test code, name, and I'm off to the races. I don't need anything else. So the minimum information you provide, you can already do, order entry, you can print basic labels, so the system will exhibit some default behavior. But then you can say, well, I would like, a specific number wheel, right? Like I would like to define my number wheels for these different, offices for different types of testing. Like, so if I wanted like for my cytology testing to have a prefix CY and then the year and then dash and whatever, like that's where you would come and, say like, oh, I want my number wheel. Hey, I'm tracking different turnaround times for these different tests. I would like, my queues to light up like a Christmas tree if, I'm late on these tests, but not if I'm late on those tests, right? Like, oh, I'll go and, put in a turnaround time template. Like, let's say if we're talking about clinical testing, right? Like you would have specific configuration that's specific for clinical tests, right? Like for cytology, it will be different types of community. So you have like one screen that's common for all types of tests. Like doesn't matter. It's like clinical microbiology or whatever. And then if you would like to get some specificity, okay, for our clinical tests, you get to, for instance, do like the range term validation, right? So you can go and define your critical ranges, absurd, into the rerun criterias. And under that, so for instance, for like certain hormones, right, you could go and say, well, I'd like a breakdown by sex. And then within female, I would like to do a separate for pregnant women. I'd like to do a separate range for pregnant women. Or if you're running like a clinical study, this particular list is extendable, right? Like medications. You could like if you're on this medication, you can have like a different type of reference range. What's defined normal and abnormal. So just this is an example of where you drill and like you can do super detailed configurations by either a basis of classification like sex or pregnant, non-pregnant, or range based, for instance, ages, right? You could go from this age to that age, and this is nested, so you can define your matrices. So you could ask like, why? Simplicity. It's complex, but you buy simplicity. Now you only need one test code because so many other LIS systems or systems that are modeling this, whenever they're faced with a complexity like that, they're like, oh, just create a new test code, just create a new test code. So you end up with you having to, instead of the system managing the complexity, you take on the responsibility for managing the complexity, because now you have to figure out when to order what test code and how to substitute one code for another. Hey, you can define the flow the way you want. So for instance, if you want to capture, for example, race up front and then like get an EGFR calculation so that the doctor doesn't have to think about it, like, and you're not over reporting, you can do that. Or you can say, no, I want to do like EGFR African American as a separate test code. Like you retain the flexibility of how you want to set it up, how your clinician population expects you to deliver those results. So that's the value of having that complexity, because at the end of the day, it buys you simplicity. At the end of the day, it should be simple. It should be really complicated for the admin to figure out. It should be really simple for the accessioner or for the histotech or for the clinical scientist who's running a plate. Like that's where the complexity will pay off in those operations. So you can do more of them per hour. You can like have the population of your employees who is getting like challenges and finding the qualified people and training them. So it's really we're basically saying front load the complexity with your software, so you can reduce the complexity in training staff and retention. So we have what we call adaptable QC. where we're not just giving you what I call sometimes like monkey see, monkey do, Levy Jennings diagrams. Like, hey, just print the diagrams, you've done your QC. No, what we do is we have a QC that's based on Six Sigma, that's basically self-monitoring and self-applying the correct Westgard rules depending on where your Sigma is. If your Sigma is very high, which basically can happen in two places, either biological variation is very wide, or your instrument is just like in top shape. It's a brand new instrument, right? Your Sigma is super high. There is no point to overload the rules with too many Westgard rules. Like you just run, three standard deviation, and that's it. And the system will automatically figure it out and apply those rules. So you will only get alerted if you are a QC manager who's working through LigoLab. You'll get alerts way before it becomes a problem. Like you will have those like early warnings where the system will say, look, the trend is not looking good. Like we're controlling the total error allowable. So either your bias or your random error is getting out of hand. So, but again, we're going to need to work with someone up front to understand, like, what is your QC? What is your QC strategy? What is the quality control rules that you're like? So we're going above and beyond in terms of like how well you want to control your QC. Sometimes organization is brand new, all the equipment is brand new. That's not going to hit the bottom line. You know what? Don't touch QC. You just want something that just prints out the reports and hands it off to the users on a daily, weekly basis. You can use the system that way. You're on a tight margin and you want to really squeeze out of the equipment that you have. Hey, and you have a really smart QC manager who can do it. That's a great power tool in the hands of that person. Like they can really squeeze a lot of margin out of old equipment. So you can, like, everybody runs controls, right? It's like what you do with the data after you've run the controls that separates kind of like the level that organization embraces QC, right? Like you can, and again, like we have to be realistic. At the end of the day, it's about the bottom line, right? Like, as I said, if equipment is new and you're like not battling a ton of like, what is it, mean downdrift or bias or like things that happen like when equipment gets aging, why get a really expensive QC manager and why like do all the work? But you know what? Three years down the line, where you're making a decision of how many instruments to replace, hey, this can make a difference. Like this can really make a difference for your bottom line. What are the primary specimens that we accept? And what to do, what types of labels, what type of aliquoting at what stage to offer. So this is where you would come and configure it. Like, so you would come and say, hey, I want to, like for thin prep, I would like to, print these labels, highlight these adequacy issues, and like make sure that something happens at accessioning and something happens at post-processing. So this is manifestation of our philosophy where we're trying to create a zone-based lab. So people, just by looking at a specimen, know what to do with it, like without having to print work lists or without having to run around and like do a lot of stuff. So what we do, we apply certain tags to specimens which get printed on the label. So the system is smart enough to understand what to do with the specimen, like which station to run it to. But it also prints it with these little codes like, oh, CTNG. That means take it to this machine in this room. It's really easy to train the users. And when you have variability in terms of sometimes we do this and sometimes we do that because client preferences are in the play, becomes super valuable. People don't need to think. They just pick up a specimen and they know which rack to put it in because it's right there on the label, right? And then, so you're looking at the screen that says, hey, if we are running this test is ordered and we've gotten a thin prep, we're going to run it on Aptima machine and we're going to add this tag to the primary specimen because that just indicates that there is molecular processing. because we might get some thin preps. There is no molecular processing. They're going to go to a different workflow. And by the way, on the Aptima, tag it with CTNG because that's where we're going to run it, so that the aliquoting label will tell the user what to do. So some of these things can be so efficient where they don't need to necessarily type anything into the LIS. It can just be, I pick up a specimen, I know what to do. I'll scan it and I'll put it in the machine. I'm done. Like it facilitates a lot of workflows like that. We can configure an automation that says, well, depending on where we ordered the test, time of the day, location, we might change some of these strategies. It will run on a different machine. It will be sent to a different lab, et cetera, et cetera. So that's kind of like the way of configuring that variability system. So this is just an example of chaining those rules so you can easily create something that's easy to maintain. So for instance, if some decisions need to be made, and you can lay them out as an algorithm to say, hey, I first want to consider if like age is less than 3, I'm doing something else. If, you know, age is greater than 3, we're going to do something entirely different. Let's assume every time you're over 3, you're an adult. You know, and we get to daisy chain these so you can build a really complex rules. And complexity versus maintainability, right? It's always this double-edged sword. We're always balancing there. So to one extent, this is a little bit harder to configure, but it's easier to understand. It's easier to maintain. If you remember from last time, I tried to give kind of a high level explanation, kind of where we control certain aspects. There's kind of families of templates that control how your, you know, report, your header, your margins, your letterhead, kind of like this is how we present ourselves. And then inside every single type of testing has their own templates on how do we present microbiology, how do we present clinical, how do we present molecular, surgical, et cetera, et cetera. So these are all configurable on the appropriate level. So if we're talking about a report, kind of high level report, you would come here and we have these various templates. I guess for this to be interesting, I'll need a preview key. So this is actually, I don't know if we've ever come to this screen. This is a way to like search across our lab information system. So this is where you see the structure, how things are organized. Like you're seeing that this is an umbrella order. Under here you have reports, right? The same order can have multiple reports underneath. So if right, so I have an accession, I have a report, and then underneath I have individual results. So I came here just to pick up an ID so I could preview a report. One of those defaults better give me something. Okay, so this is one some sample report, right? So anything that you would be configuring at the top. I mean, obviously this is a demo system, so people mess it up, but you have control. So what we could do is we could preview it as a floating PDF. So that gives us a grid to work with. PDF floating. So if I wanted to move any of these attributes, all I have to do is just like figure out where to take them. So I could, for example, like patient demographics. I could move it up or I could move it down, right? And it would just shift slightly. So I have complete control over a report presentation. So in a very similar manner, kind of to showcase the engine. So this was like the PDF engine that controls reporting. In a very, very similar manner, you're controlling like labels. So if we go to specimens, and you would have you can have zebra labels where in a very similar way you're controlling like what gets shown on a zebra. Again, we have built-in editor that allows you to build your zebra with barcodes and data that's shown. We also support Dymo templates. We support some printers that can accept a PDF, or some completely custom industrial printers that basically take their own data conversion, and we can support a proxy template. Basically, some of them ask you to export like a number of delimited fields, like give me a pipe delimited field and I'll print a barcode for a cassette, like, or for a slide. So that's another, like, all of these little I mean, this when I was saying earlier, like these are like things that cut across the LIS functionality. It doesn't matter which ecosystem you're working on, you're gonna be configuring reports, you're gonna be configuring labels, you're gonna be running custom reports or tracking specimens. Like these are the functionalities of the system that will support those workflows.